Hey y'all, it's Miss Campbell. Sorry I could not be there today. I got called into a meeting I had to go to. So I'll see if it lasted or otherwise I'll for now, we'll go ahead, we'll get started on our next packet here. Go ahead and make sure you've grabbed one from the back counter. It should have this butterfly and these flowers on it. Okay, it should say Geometry Pre-AP. So the next thing that we're going to be learning about is polygons. And then we're going to go into quadrilaterals. So first we're going to learn about the angles inside of polygons, and they have, there's some formulas that we're going to use to deal with their interior angles and then their exterior angles as well. So first, the definition. So a polygon is a closed figure formed by coplanar segments where sides that have a common endpoint are non-collinear. So that just means there's no overlapping sides. And then each side intersects exactly two other sides, but only at the endpoints. So basically the sides don't cross. So there's no overlapping sides and your sides aren't crossing each other. So we've got some examples here. This first polygon, you can name it A, B, C, D, E, F, or you could name it D, C, B, A, F, E. Basically, you pick a point to start at and you go the same direction around the shape. You can go left or right, it doesn't matter, but you can't just like hop around and go. You have to like follow the shape. Okay, this one here, we could call it G, K, J, I, H, right? Or you could call it H, I, J, K, G. Just you pick a spot and you go around in the same direction, whichever way you're going to go. So we'll just say G, H, I, J, K. Okay, and then here would be an example of not a polygon, because right here, you see where these four segments come together? They cross, they overlap. So that is not a polygon. So now we have two different types of polygons. There is convex polygons. So these are the ones where no sides basically go into the interior of the polygon, and it doesn't have any diagonals with points outside the polygon. So y'all, a diagonal is from one corner of the polygon to another. So you can see these dashed lines in here. These are all diagonals of the polygon, and they're all going like from inside to inside. They don't have anywhere that they can have a diagonal going outside. And a diagonal is also not from like a point to the point right next to it. You have to like skip at least a point. So I could go from A to T, but not A to R. So AR would not be a diagonal, but AT would be. So basically, I like to think of convex polygons as all the points go out. Okay, and then you have the other one, a concave polygon. So that's where it doesn't meet the definition of convex. So it's also called non-convex. So basically, you can see here, you see how this point K, we have this line, it's going towards the interior of the polygon. So you can think concave is like they point in, like they make like a little cave, if you will. Okay, so points in. So the side is caved in, if you will. And the diagonals here, they can have a diagonal with points outside the polygon. So see the diagonal between M and W? That diagonal is outside of the polygon. It's still a diagonal, but it's outside the polygon. So that's how it's concave. So now we're going to, and then another example would be for concave would be the polygon that we call GHIJK up above. So the second polygon that we have there. So if you want to see another example of that. So now we're going to name some polygons, and you got to know the names of these and what that means for how many sides it has so that you can be ready for that. So we all know a three-sided polygon, triangle. That's the basic one, so triangle. Okay, a four-sided polygon is a quadrilateral. Okay, and quadrilaterals, there's familiar shapes in there that you would know, but their general name is quadrilateral. Okay, the next one that we have is a five-sided one, so that's a pentagon. And then six-sided hexagon. Okay, now a seven-sided is going to be a heptagon. Heptagon, okay, a heptagon. 8-sided octagon, okay. 9-sided is a nonagon. 10-sided is a decagon, okay. Okay, and 11-sided is a hendecagon. Okay, or we'll just generally call it an 11gon, okay? And then a 12-sided is a dodecagon. All right, typically you need like 3 through 10, okay? 11, not so much. 12, maybe. And then a polygon with n sides is also called an n-gon. So sometimes we're going to ask you to find how many sides it is, and that would just be called an n-gon. Okay, and then a vocab tip. The diagonal of a polygon is a segment that connects two non-consecutive vertices. So remember how before I was saying you have to like skip a point before you can draw that diagonal? That's what that means. So turn the page here. We have our theorem here. It's the polygon interior angle sum theorem. So in a convex polygon, so convex pointing out, with n sides, the sum of the measures of the interior angles is n minus 2 times 180. And this is derived from, you can draw a bunch of triangles inside a polygon, and we know that the angles inside of a polygon all add up to 100, or sorry, inside of a triangle all add up to 180. So basically you figure out how many triangles you can have in here, and that's how many, that's the degree there. So the interior angles. So inside here in the polygon, we have all of these angles, and they're interior because they're on the insides, right? Now, I marked them just to show you. That doesn't necessarily mean they're congruent, okay? But basically what we're going to do is we're going to take the number of sides of our polygon, put it into this formula here, and then that would be what all of the angles of that polygon should have to add up to based on the number of sides. So it says, find the sum of the interior angles of a nonagon. So remember, a nonagon, that's 9 sides. So n equals 9. So we would plug it in here. So we would do 9 minus 2 times 180. And you just type, so 9 minus 2 is 7 times 180 is 1,260 degrees. So that's what all of the angles inside a nonagon should add up to. All right, so now the next one here says, find the value of y. So in order to find the value of y, I have to find out what all, and let's count here. We got 1, 2, 3, 4, 5. So there's 5 sides, so that means there's 5 angles. Okay, I'd have to figure out what all 5 of these angles should add up to based on the fact that this is a pentagon, 5-sided polygon. And then I can write an equation to find y. So step 1 is you're going to find the sum. So we have 5 sides. We have 5 minus 2 times 180. So that's 3 times 180. So that should add up to 540 degrees. So if I added all 5 of the angles, it should add up to 540. And then step 2 is you're going to write and solve your equation. All right, so let's write our equation. So I'm just going to start at t. So we have 3y minus 25 for that angle plus 120. Because remember, it's the sum of the angles, so we're adding them all together. So 2y minus 5 for x plus 2y at A plus 2y at angle S. Okay, so that's 1, 2, 3, 4, 5. And all 5 of those angles should add up to 540 because we have a pentagon here. And so now we'll just combine like terms and solve. So we have a 3y, a 2y, a 2y, and a 2y. So 2, 4, 6, 7, 8, 9. So 9y. Okay, and then look, we got 120. And we have minus 25 and minus 5. So 120 minus 30 will give us 90. So 9y plus 90 equals 540. And then now we'll go on to solve. So I'll do 540 minus 90, which gives me 450. So 9y equals 450, and then divide by 9. So y equals 15. So you have to use the fact that you know that all the angles should add up to 540 because it's a pentagon, and then write your equation and set it equal to that sum so that you can go from there. All right, now it says a convex polygon with the sum of the angles is 1,800 interior angles, and it says how many sides. So we have our formula n minus 2 times 180, and that's equal to the sum of all the angles. So they've told us the sum. So we're having to work backwards here. So we're trying to find n. So we go over here. We have to get rid of this 180. So I have to divide by 180 first, because that n minus 2, that's in parentheses. So don't touch that yet. So now we have n minus 2 equals, and if you do 1,800 divided by 180, you should get 10. And then we add 2. So n equals 12. So it's a 12-sided polygon. So that's the basic one there. Okay, now we're going to turn the page here. We're going to move on to the next section of the notes there. And we're going to talk about exterior angles, and this will work for any polygon. So in a convex polygon, so convex again, the sum of the exterior angles is going to be 360 degrees. So if you see, we got a polygon in here, and then we got all these little sides coming off of it. Those are your exterior angles on the outside. So we have a 60-degree one, we have an 80, a 68, this one labeled B. But then here we see this 140. The 140 is the interior, but we see we've got a straight line here, right? This 140 and this angle that's out here, they should be supplementary because they're a linear pair. So basically we're going to do 180, because that's what a straight line is, right? That's what a linear pair adds up to. 180 minus 140. So the exterior angle for that part is going to be 40. So now we just learned that all the exterior angles have to add up to 360. And we're trying to find this angle labeled B. So we're going to write a little equation. So 68 plus 84 plus 60 plus 40 plus B equals 360. So now just combine like terms. So 68 plus 84 plus 60 plus 40. So we have 252. So 252 plus B equals 360. And then just subtract. So B equals 360 minus 252. We get 108. So there you go. Right, so the next one here then, they want us to find the measure of A, or the value of A. And we can see we've got these 3 angles that are marked to the same. So that means that they are all A degrees, whatever that is. So now we're going to write up our equation. And again, these are all exterior angles here. So it's going to be equal to 360. But before we actually get started, we got to figure out this exterior angle right there. So we got to do 180 minus 68. Okay, and that will give us the exterior one there. And so it's 112. So now we can go write our equation. So first, I'm going to count the A's. We have 1, 2, 3. So I have 3A plus the 112 plus the 43 plus 69. And that should equal to 360 because these are all exterior angles. So now combine like terms. So 112 plus 43 plus 69. So 224. So 3A plus 224 equals 360. Subtract 224. So we get 3A is 136. And then we'll divide by 3. And it gives you a fraction, but that's okay. We can just turn it into, like, again, it will specify for you, but you can round to the nearest tenth. So do Control Enter there. So you get 45.3 degrees, and it's 3 repeating, so a little bit. All right. So now we're going to go on here a little bit more detail on it. So an equilateral polygon means all sides are congruent, and an equiangular polygon means all angles are congruent. And then now that brings us to the definition of a regular polygon. So the definition of a regular polygon is a convex polygon with all sides congruent and all angles congruent. So you can have a regular triangle, so that would be an equilateral triangle, or you can have a regular quadrilateral, which would be a square, or you can have a regular pentagon, a regular hexagon, and so forth. So now it says we've got, based on the fact that all of our sides and all of our angles are congruent on these regular polygons, that's going to tell us more information about a single interior angle and a single exterior angle, because it's going to be all evenly divided because everything is it's regular. Everything's congruent. So to find the measure of each angle, so a single interior angle of the regular polygon, the total is divided by the number of sides. So here's your formula. So if you want to know each exterior angle, basically you take the 360 and you divide it by how many sides you got. And that's one exterior angle. Okay. Or if they tell you the interior angle, then you could subtract it from 180 and that would give you the exterior. We did that in the earlier problems. Okay. Now each interior angle. So again, we find the sum, so that n minus 2 times 180, but then you divide it amongst how many sides there are. Okay. And again, you can find the interior angle by subtracting the exterior angle from 180. So we'll get to that. So it says find the measure of each interior angle of a regular dodecagon. So dodecagon, so that's 12 sides. So we will go in here. So we would do 12 minus 2 times 180. And if we did that, that would give us the sum. That would give us all the interior angles added together. But I want just a single one, so I have to divide it by how many angles there are. And how many angles there are is the same as how many sides there are, so there's 12. So we'll just type this in your calculator. So 10 times 180, divide by 12, and you get 150. So each angle inside a dodecagon is 150. All right, now, if each interior angle of a regular polygon is 157.5 degrees, how many sides does it have? So we're going to have to reverse our formula here. So we don't know the number of sides. So we have n minus 2 times 180. And again, if we were doing the sum, we would stop there. But they told us each interior one. So we have to divide by the number of sides. And they've told us what it's equal to. It's 157.5. So now we're going to have to use our algebra skills to solve this for n. So what we're going to do, I'll rewrite it here so you can see what exactly we do. Okay, so step 1 is going to multiply by n and multiply by n. So you're going to end up with n minus 2 times 180 equals 157.5 n. Okay, and then now we're going to do the distributive property. So we're going to multiply the 180 into both of these. So we have 180n minus, and then 180 times 2, 360. Sorry. Equals 157.5 n. Okay. And so now from there, we go on here and we'll combine like terms. So I'm going to subtract 157.5 n from 180 n. I'm going to move the 360 over there. So 180 minus 157.5 will give you 22.5. So we have 22.5 n equals, and then remember this 360, when I move it over here, is going to become positive. And then we'll divide by 22.5. So 360 divided by 22.5. And that will tell us that we have 16 sides. So y'all, it's going to be the same process no matter what your number comes out to be here. It's just you write the formula, you say each one's equal to this, and then it's the same algebra steps that you're going to do. So just kind of memorize those steps there. So now here's the next one. It says, if the measure of an exterior angle, or the measure of an exterior angle of a polygon is given, find the number of sides of the polygon. So this is one exterior angle. And remember, one exterior angle is 360 divided by n. So we have 360 divided by n is equal to 30. So now we just got to do our algebra here. So we got to multiply by n, multiply by n. So 360 is 30n. So divide by 30, divide by 30. So 360 divided by 30 should give you 12. So the number of sides for this is 12. And then you can do the same thing here. 360 divided by n equals 8. Now we'll just multiply by n on both sides. So 360 equals 8n. And so divide by 8. So 360 divided by 8. So it's going to have 45 sides. Yes, you can have a 45-sided polygon. Okay, they can get a lot of sides. So, y'all, the next next several pages would be the practice that you guys are going to be working on here. I will go through and I will make a note on Canvas exactly which problems that I would want for you to do from here. But there's definitely more than enough practice on here. So please go look on the announcement from Canvas to see like the specific problems from both of these that I want you to do. And then there's some extra ones that you guys can work on as well. And if you have any questions, I'd be happy to answer them on Friday. So see you guys then. Have a great day.